Hello everyone. Hello everyone. Join as much as possible. So today we are doing a revision for dimensional analysis class 11 chapter number 1 as exams are coming closer. So we are doing this dimensional analysis. So we know that derived units of all the physical quantities can be suitably expressed in terms of the fundamental unit like a mass, length, time, and that is raised to some power. Okay, so we can write here mass in terms of capital M, and that is enclosing with square bracket, and then length we are writing capital L and enclosing in the square bracket. Then time is there, which we are writing in terms of capital T and again enclosing in the square bracket. So these are the three fundamental quantities where we are expressing our dimensions. Okay, for example, very simple example we can take. If we have a area, okay, and suppose if I have here rectangle and if I want to find out the area, then area is nothing but length into breadth. Okay, and length also we are measuring in terms of meter, and breadth also we are measuring in terms of meter. That means we are expressing this area in terms of meter square, and if I want to express in the standard dimensional form, then m raised to 0, because here this is meter is related to length. Okay, so mass is 0, length power is nothing but 2 because meter square, and time becomes how much here? 0. So these are the simple methods to find out the dimensions. So this is one example for area. Now suppose if I want to find out the volume. The volume is nothing but what? Length into breadth into height. Volume is nothing but length into breadth into height. That is meter into meter into meter. That is nothing but meter cube. So in dimensional form we can write m0 L raised to 3 and T raised to 0. So like this we have to obtain the dimensions. Okay, then we can take a density. Density is nothing but mass by volume. We can write density is nothing but mass by volume. Okay, mass here only one mass is there, and this dimension m, capital M, is related to mass only. So 1 volume is here divided by, that is in the denominator. So we know that if 1 raised to 1 upon 2, nothing is there, that means it's raised to 1. So whenever we are taking this 2 up, then we are writing 1 into 2 raised to minus 1. So similarly here volume, length is there. Here length, that is L raised to 3. When we are taking up, we are writing minus 3, and time is absent here. So the dimensions for dimension density is nothing but m1 L raised to 3 T raised to 0. Okay. Now similarly we can find out for the velocity. Velocity is nothing but what? Or we can take the units for velocity. Velocity we are measuring in terms of meter per second. Okay, meter which is related to length and second which is related to time. Okay, so we can take here, we can write here m, here mass is not available, means absent, that is 0. Length is there raised to 1, time is there but that is in the denominator, and then we are transposing up, so it will become minus 1. So these are the dimensions for velocity. Then if we take acceleration, that is nothing but its unit is meter per second square. Then we can write here again mass is 0, meter is related to length 1, and seconds raised to 2, that is minus 2, because second is going what? In the numerator. Okay, then we can find out the momentum also. We know that momentum, or we can write momentum we are representing in terms of P. P is nothing but mass into volume. So volume, just now I shown you what are the dimensions for volume, that is L raised to 3. So here mass is there 1, sorry, not volume, momentum is nothing but mass into velocity, sorry. So velocity is nothing but meter per second. Just now here only I have the dimensions. So mass is here present, so that's what I wrote, m raised to 1. Velocity is nothing but L raised to 1 and T raised to minus 1. So these are the dimensions for momentum. Okay, then we want to find out the dimensions for force. Okay, so force के लिए dimensions we have, what is the formula for force? Force is nothing but we can write mass into acceleration. Force is nothing but mass into acceleration. So mass is nothing but m1, acceleration meter per second square, L raised to 1, again T raised to minus 2. So this is very important dimension. We are using here everywhere this force dimension. Force F is nothing but m1 L1 T minus 2. Okay. So these are the dimensions for the force. So we can find out pressure also. Pressure is nothing but F by A, that is force by area. So here force dimensions just now we calculated. So force is nothing but here m1 L1 T minus 2 and area is nothing but L raised to 2. So simplify this, m1 L raised to 2 means L raised to 1 minus 2 T raised to minus 2. So this will become m raised to 1 L raised to minus 1 and T raised to minus 2. These are the dimensions for the pressure. Okay. If we take a work or any energy, okay, if we take a work is nothing but what? Force into displacement. Okay. So work is nothing but force into displacement. Force के dimensions we already got, that is m1 L1 T raised to minus 2 and displacement that is related to length. So L raised to 1. So we can write it as here m1 L plus 1 means these powers are get added, L raised to 2 T raised to minus 2. So these are the dimensions for work done. So similarly we can find it out, this work done is nothing but one kind of energy only. And here if we take mechanical or heat energy, light energy, any energy if you are taking, kinetic energy or potential energy, the dimensions will remain same. Okay, because everything we are measuring in terms of joule, so dimensions will remain same over here. Okay, so now if we take the gravitational constant, okay, so whenever we study the concept gravitational force, so after deriving that final expression we will get the gravitational constant, and that gravitational constant is nothing but force into distance square. Okay, that is gravitational constant is nothing but capital G, F into D square, okay, divided by we have mass into product of the masses, so mass raised to 2, or we can write mass into mass. Okay, so force dimensions we know m1 L1 T minus 2. Here distance is there, so distance, that means here actually distance is there but its power is 2. So 1 into 2, that we can write it as 2 over here, divided by mass into mass, that means mass raised to 2. So no need to write L and T here because both were absent. Okay. So we can write it as here, this 2 will go up. So 1 minus 2 is nothing but minus 1. L raised to 1 plus L raised to 2, that is nothing but L raised to 3 and T raised to minus 2. So these are the dimensions for the gravitational constant capital G. Okay, and gravitational constant SI unit is Newton meter square per kg square. Okay, these are the dimensions, and that means these are the SI units. Okay, so here if we take a surface energy, okay, so surface energy is nothing but what? Surface energy, already we finished the liquid chapter. So surface energy is nothing but energy by area, that is work done by area. Okay, surface energy work done by area. Just now we find it out the dimensions for the work done, that is m1 l raised to 2 t raised to minus 2, okay, and area is nothing but here l raised to 2, okay, that is we are measuring in terms of meter square. So we will get surface energy is equal to, here 2 and 2 get cancelled, l raised to 2 l raised to 2, so m l raised to 0 and t raised to minus 2. So these are the dimensions for surface energy, okay. So similarly we can find it out the torque also. Torque tau, we can calculate tau is equal to force into perpendicular distance, okay. Force dimensions we know m1 l1 t minus 2, and perpendicular distance that is related to length raised to 1. So here m1 l raised to 2 t raised to minus 2. So this is nothing but what? Tau. Tau is nothing but here torque, that is it is also known as a couple. Then one more we can do frequency. Frequency, so we know that 1 upon t. So frequency dimensions are m raised to 0, l raised to 0 and t raised to minus 1. So these are the dimensions for the frequency, okay. And similarly you can make a combination and find out different dimensions. If we take again moment of inertia, okay, moment, I think maybe you are getting this dimension. This is just a revision because already we finished this everything at the beginning of the year. Now you have an exam, so I am revising this. So here we can, if we take an example of moment of inertia, so here if we take moment of inertia, that is mass into radius of gyration ka square, mr square. So mass is nothing but 1, and what is the radius of gyration ka square is nothing but l raised to 2, okay. So time is not there here, so dimensions are nothing but m1 l raised to 2 and t raised to 0. So these are the dimensions for moment of inertia. Hope you are getting. And then here some quantities we have, that quantities are dimensionless. For example, strain is dimensionless, okay. Then even angle is nothing but arc by radius, and that is also dimensionless, but its SI unit is radian, okay. So strain is also dimensionless because there is a change in length or change in the volume we are taking, so that is also dimensionless, okay. I hope you understood the basics of this chapter. In next class we can do some examples based on the dimensional analysis by different methods. Thank you.